Unit 5 addresses transportation design projects, which typically deal with corridors for roads and highways, intersections, road reconstruction projects, interchange design, and that sort of thing. The exercises in Lesson 1 teach you how to create an alignment from objects, teach you how to label an alignment, create an alignment using the alignment layout tools. You learn how to edit an alignment. In exercise 5, you learn how to apply superelevation to an alignment, and then in exercise 6, you learn how to create alignment, offset alignments, and widenings. In the first two exercises, mimic the steps covered in the alignment section in the third unit of this, which is on land development. So in exercise 1, you learn how to create an alignment from a polyline. And then in exercise 2, you learn how to label an alignment using the station labels and the segment labels. These can be learned in more detail or reviewed in more detail if you go back to the third unit's lesson on alignments. In exercise 3, you learn how to create an alignment using commands on the Layout Tools toolbar. And the Layout Tools toolbar offers quite a bit of functionality for creating complex alignment geometry that you may encounter in a typical transportation engineering project. For instance, spirals, compound spirals, reverse curves. So let's have a look. Here we have the starting of an alignment. And if we went to Alignment menu, we can go to the Alignment Creation Tools toolbar, and let's call this 8th Avenue. The alignment style is proposed, and the alignment label set is all labels for now. So what we have in the drawing here are a number of just AutoCAD entities. Now, we could have created from objects, but we're going to go a little bit of a different route here. On this drop-down menu, you have an option to convert AutoCAD lines and arcs. So if we pick that, on the command line you're prompted to pick the line or arc to convert, and we'll just slowly pick these one by one. And that has created an alignment object from those lines and arcs. What I could do now is grip the alignment, right-click, display order, and send it back. And there's the original arcs and lines, and I can just pick those again to erase those because we no longer need those lines and arcs. So we can add another curve onto here or a spiral. There's a number of different commands. Perhaps we want to add a tangent, fixed line 2 points up to here. There's a tangent. This is all part of the same alignment. And now perhaps I'd like to fit a curve between two entities in radius. And then if we pick the incoming tangent and the outgoing tangent, and at the command line the curve solution angle is less than 180. And we're also being prompted for a radius. Let's go with 100 feet. And so there's a 100-foot radius here. And that curve can obviously be edited to increase the size. So a number of different commands in here. When you go through the actual steps in the lesson, there's commands that show you how to create some more complex geometry with spirals and so forth. In the fourth exercise, you learn how to graphically edit an alignment using grips. If you were to move the PI, you can see how you can change the position of that PI. You can change the angle of a tangent. You can change the size of a curve using grips. So grip editing is a powerful method to edit an alignment. And you can also, on the Alignment Layout Tools toolbar, if it's not visible, you can grip the alignment. You can right-click and select Edit Alignment Geometry. And on the Alignment Layout Tools toolbar, you have the Alignment Grid View. And what this allows you to do is to edit the geometry in the table. So I can now go back and say, well, let's change this to a radius of 300. And you can see how the geometry updates automatically in the drawing. So you can edit the alignment using grips, and you can also edit the alignment data in a table. Furthermore, you can apply design speeds to an alignment. So let's have another look at a data set here. We'll go to this data set here. And when you create an alignment, you can assign a design speed. So if we were to modify the properties of this alignment, under the Design Criteria tab, you can see that we've assigned a design speed of 40 miles per hour. And we've turned on the use of criteria-based design and referenced a particular design criteria file. Well, what's happening here with this exclamation mark, it's letting us know that this curve is substandard. So if we grip the alignment and edit the alignment geometry, and if we were to look at the data in the grid view here, you can see here where it's letting us know that that curve is substandard based on that table. So right now it's saying that the length of the radius of the curve is 500, but from the design table the minimum radius is 510. So if we change that value in here to 510, you'll notice that the curve is no longer substandard and that the warning symbol has been removed. So when you create the alignment using the alignment creation tools, you can right away assign a design speed and design criteria to that alignment, or you can assign design speed and design criteria by modifying the alignment properties after you have created the alignment. So you don't need to assign the design speed right away. In exercise 5, you learn how to apply superelevation. And in order to apply superelevation, you need to first assign the design speed to the alignment. You need to then calculate the superelevation values. And the way this works is that when you create your cross-section subassemblies read the superelevation values at the specific station locations. And here's a diagram that's showing how the superelevation of the edge of pavement left and the edge of pavement right interrelate with the cross sections here. And here's the superelevation table. So let's go through that. We'll open up a drawing here. Exercise 5. And if we modify the properties of the alignment, you'll see that we have a design speed assigned to it. We have a design criteria file assigned, and we're using the 6% superelevation table. If we go to the superelevation tab, there's no superelevation parameters assigned yet. You can either insert manual stations or delete stations, but this one here allows you to set the properties from the table, and you have a superelevation region for each curve. Let's just delete the we won't bother applying superelevation to the first two regions. We'll just do it to the third region. And you can see that it's adopted the parameters that we assigned to the alignment. And if we just click OK, you can see now that you've got the superelevation calculated for the first, second, and third regions, which are the individual curves. And these up and down arrows indicate where your run out and run off lengths are exceeding the available distance given the alignment geometry. But we're going to ignore the first two curves, so I'll pick the first station and then pick the last station for the second region, and we'll delete those transition stations. So now we have the superelevation for just the third curve, and you can see where you've got your description and then the superelevation rates, and these can be changed or edited in any fashion. But once again, it's the subassemblies that read your superelevation values at any particular station location. So now we have superelevation assigned to that alignment. And this is the result of applying superelevation to the alignment, is having your cross sections read those values. And in the last exercise, you learn how to create offsets and widenings on alignment. And these are really powerful because they will update when you change your alignment centerline. So it's a different category of an alignment, the offset alignment, and it's associated with the centerline alignment. So let's open the data set and we'll have a look at that. So if we create an offset alignment to 8th Avenue, So I could pick the alignment here. That is your 8th Avenue alignment. If we go to the Create Design panel and Alignment, you can create an offset alignment here. Pick the centerline alignment. Here's the alignment that we're offsetting. Here's your naming template for the offset alignments. You can pick a side. So we'll go 12 feet to the left and 12 feet to the right. And if I click OK, you can see 2 alignments. Now let's remove those labels. We didn't need to have those labels. I'll grip the first one. Edit alignment labels. We'll delete all the labels on that one. Typically you're not labeling these offset alignments. We'll do the same on the other one. Edit alignment labels. And those labels have been removed. Now those offset alignments can be found in Prospector. If I expand alignments, there's your 2 offset alignments. But what you will note is that when you edit the geometry of the offset alignment, or the centerline alignment, you'll notice that the geometry of the offset alignment follows. So this is a very nice way to generate offset geometry from centerline geometry that will react with changes to that centerline geometry. And in here, if I right click, I can edit the offset parameters. And now here's the offsets, -12. Well, maybe on the left side we wanted -14. And you can see when you, oops, let's change that, make sure that's correct, -14. And that now will update so you can see you've got a 14-foot offset on the left-hand side. And if I grip the alignment, you can see here that it is an offset alignment. It's recognizing that as an offset alignment, and I get commands that allow me to modify the parameters as I did just now from Prospector or add widenings. And here you can see a diagram showing how the offset alignment will vary or will change with adjustments to the centerline alignment. And then in the final step you will add a widening, which can be used to form an acceleration or a deceleration lane with entry and exit tapers. And that concludes the discussion in Unit 5 Transportation, Lesson 1 on alignments.